Hi everyone, welcome back to our channel. Today we will be looking at the PAW6 Inlet Test Case from the 6th AIAA Aerodynamics workshop. In our previous video, we showed you how to integrate the topology for the bleed holes and the vortex generators. In this video, which is part 4 of the series, we will be showing you how to mesh the cowl lip and manually create a nested topology before addressing the spike. Extending the topology, we take the corners assigned to the end plane between the cowl and center body and wrap it as such. We use the upper row of corners and position it to create one part of the O grid. Now copy those corners to above the cowl lip. Copy the remaining corners from the wrapped sheet without links to above the cowl lip. Now link the corners as such. Copy all the corners above the cowl lip with links to one end of the fluid domain. Now link the remaining corners to create a block as shown and complete the O grid around the cowl. Add an insert in the created block. This layer is now wrapped to some distance before the end plane at the inlet. Clamp nesting. A clamp nest is a nested topology which is used to reduce the number of blocks between layers of corner sheets by creating a loop back structure. We use a clamp nest to reduce the number of vertical inserts in the topology, which will be helpful for us in dealing with the sharp spike, as to having too many vertical inserts will lead to too many grid points being present at the tip of the spike. We skip a layer of corners while creating the loop back structure, as it would otherwise result in a singularity there. The blocks at the two ends are also left unchanged, as creating the loop back structure at the ends results in a singularity on the two wedge end planes. We create this on GridPro by manually selecting the sheet of corners, copy them to their respective positions using the work plane, and linking them appropriately. Add inserts along the length of the cowl surface. Some repositioning along the cowl lip is necessary. Complete the end plane assignments. To reduce time, we will run grid only on the newly created section. Thus, an additional end plane is required. Assessing the grid. After running grid for a few thousand sweeps, we see that the generated grid is of good quality, with the cowl lip being captured accurately, which is vital as that is the region where the cowl shock is formed. The nested topology is also beautifully smooth, and the blocks are reduced appropriately, which not only aids us in reducing the cell count near the inlet, but this also helps in reducing simulation time, as the flow near the inlet is mostly laminar in nature. In our next video, we will show you how to address the sharp spike inlet. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for more videos. If you have any questions or comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Follow us on our social media pages. Links are posted in the description.